Hello everyone, welcome to the podcast with Navneet show. I am your host Navneet Singh Rajput. Today we are thrilled to have Mangesh Thakare in this show. He is having 21 plus year of experience in the VLSI industry. So with him we have discussed about the current investment is happening in the semiconductor sector, how that AI is going to transform design verification process, and we have seen the downfall in the VLSI industry from the last year. So many of the freshers and experienced guys having queries regarding that. So we have covered that thing also. So hope you guys will enjoy this show. So let's start this show. Yeah, hi Mangesh. Thanks for joining us.
Thank you.
So could you share your journey, how in the VLSI industry, how you started from the beginning, and now you are the co-founder in the Liptus Technologies. So can you please share your journey?
Okay, yeah, thanks for asking. So I started my career around 21 years back in a company named as Axonet Communications. So it was in the year 2003. So I got an opportunity as a campus. I was very lucky, I would say, that time, because like one guy from my college got into semiconductor, and I got that opportunity. I was very happy about that. So that's when I started my career. Worked there for 4 years, and the Paxnet was acquired by Connection, and then I came to Bangalore. Probably we'll talk later, but I remember one good memory. The Paxnet was a very cool company.
Okay.
Okay, so I had my selection done in final year, and then I went to HR, Paxnet HR, saying that okay, now I have a year ahead before I join you. So what do you want me to do in this year? And they're like, should I study VLSI because I can do that, or should I do this? Should I do that? I was very excited, and he said like, okay, you don't worry. Whatever required for us, we will teach you. You complete your course properly,
Okay.
and whatever is your regular curriculum,
Okay.
and whatever you want to pursue as a part of that. Yeah, so I dropped, I didn't take the VLSA as elective, and instead I took a system programming.
Okay.
So that was like very odd, and everyone was asking like, why you're doing this? I said, see, my company is okay with that, so why not do that? Anyway, they said they'll be teaching everything, so why not learn something else? So with that, I started my career. Then I came to Bangalore, joined Cortina Systems. Worked there for 3 years. So till this point, everything was into networking.
Okay.
Yeah, we were working into some industry called as Ethernet Passive Optical Network. Then we have EPON, another is GPON. So those technologies we worked predominantly. Initially, I started my career doing design. And then I got motivated to do verification.
Okay.
Somehow, it clicked me more than design. So then I completely shifted into verification side.
Okay.
So post that, I came to services industry. I had a stint with Mirafra and Tech. And then we, along with my boss, started CDM systems.
Okay.
So I joined him from the day one. And we had a good journey, like 10 years we were there. We worked for multiple customers. So the services industry experience was totally different from the product side.
Okay.
So product side, I was always focused on my work. Didn't bother about like what is happening, who is doing what, and probably how can we take it forward. So pretty much once my tape out is done, I am done, that kind of a view. But in services, we got a wider perspective of looking at our projects. We're also trying to look what value adds we can do to customers. Because it's not like that, okay, we have a one product line and we have to keep doing that. And in those kind of work, the innovation keeps happening pretty much automatically, right? You face a problem, you solve it. And you have that kind of expertise also. You're working on that particular project or with that particular methodology for quite some time. So it comes straightforward. When we started working in semiconductor, it was not that straightforward, because 1 year you are with some customer, and next year you might be working for somebody else. So definitely, like, there's a lot of change of environment, change of people, change of technology. Yeah, a lot of things are there, but it keeps adding value to that. So like, as and when we started with next set of customers, it became be easier basically. So that we can apply also what we have learned into, say, one place, their approach, right? We don't bring in technology, but definitely we bring the approach, right? Somewhere they are doing it in a different way. So can that different way be beneficial or useful here, right? So we kind of try to think in that direction. And whenever you see something, we try to correlate with so many things that we have seen in past. So that kind of helped. Yeah. So that was what like Cerium systems was about. Yeah. And now we are here at Liptus. We're starting fresh again.
And one more thing, like you worked at 21-year experience in that industry. So what changes have you seen? What transition have you seen in this industry?
Yeah, means from India perspective, the industry has become big. Right? When we compare like 20 years back, we had like a few set of companies working in Bangalore or working in India. But in last 20 years, you see pretty much all big companies are there, big product companies are there. There's a good number of services companies in India. So that's a one change. So like, if we want to put in the perspective of for say like a regular we're talking about the students, right? So for them the number of opportunities are more. Previously the number of opportunities were pretty less.
Okay.
Yeah. Next one is what I have seen is in set of tools, right? Whatever we are using. So initially the tools were not so stable.
Okay.
Yeah. So we have to be very careful when we are coding that the tool should not interpret in any other way. And we used to get frequently we used to run into tool issues.
Okay.
Like you wrote a code in certain way, when you simulate it, it's not doing the exactly same way. Then you go back to the tool vendor, ask them, they will fix it, you get it back basically. From that time to this, right now the tools are way more sophisticated.
Okay.
You can simply you can code the way you want, pretty much say design or verification, and tools are capable of handling that. They're able to simulate those things.
Okay.
Yeah, so that is one tool, one change in the tools. Next change, which is impacting or which I see is very much useful for us, is the compute.
Okay.
The compute has expanded a lot, right? Like, what used to take like a 1 day of simulation now gets done in few hours. Right, the same same test cases, right? So that definitely has improved a lot. Yeah. So when you have like a lot of compute coming in, lot of upsides on this side, so another change is the designs have become bigger now, right? The verification environment is bigger.
Okay.
So compared to past. Anyway, this is the trend also, right? Like this is what anyone would expect it to go, right? Like we should be able to do more and more stuff in the same size. So that's another change which is good for us. Yeah, and one more thing is nowadays we have a lot of IPs and VIPs available to complete a project. Right. Okay. So there was a time where everything needed to be coded in particular project. So you didn't have, say, you need a UART, probably you will end up coding it. You need a I2C, you will end up coding it. You need USB, you definitely had to code it yourself, right? Nowadays we don't see the need to code any of those IPs or VIPs, right? We can simply get all the components and stitch them and probably start working towards the tape out. So that has helped a lot. So now we can tape out chips in a shorter time compared to what we were doing that.
Okay.
Yeah, sometime back.
So when we talk about that VLSI in India, so now we have seen like since previous years, last 1-2 years, the big investment is happening in India in the semiconductor.
Yes.
So how do you see like how it is going to impact in the future in India, that VLSI sector?
Yeah, investment is always welcome, right?
Correct.
Especially when it is in our industry. So anyways, it's still the initial stage to see where we are going. So for whatever interactions we had with our colleagues in the industry, it seems to be going in the positive direction. So there are a lot of design starts in India. So like, when people are thinking that okay, they want to do or they can do, right, I guess that's a good beginning. And so that's a positive sign for that investment will pay off in India. That is what I see. So initially the designs will be smaller designs. We may not, or in general, see anyone decides to do any design, probably they will not aim for a very huge chip here, but mostly the smaller chip. Then the system gets proven, right? The whole ecosystem is proved, and then the complexity or the size of the chips will increase, or what kind of functionalities we will put into the chips will increase. So maybe IoTs or RISC-based chips will come first.
Okay.
That's what my understanding is. Another thing is some industries where you need a very high level of compliance that may not directly happen here. If some new fab is coming for it, they also need to prove. If any design house is coming, they also need to prove. But if existing companies, if they think if they start using the ecosystem or whenever it comes up, that will be a game changer then.
Okay. Now, if you talk about the product companies, now we know Intel, AMD. Mainly, I'm focusing on the processors. So, do you think India is also moving towards to build their own product?
It is not about like India. It is always about the companies, right?
Okay.
So and see, right now it's a fact that most of the companies they have started in US or Europe.
Okay.
Right. So and that's the edge they have. We had few companies in India. They were later acquired or by other big companies. Yeah, so it's more like whether it's an India-owned company or Europe-owned company, it will benefit us if that work is happening in India instead of getting it done completely outside. Yeah, so whatever happens is going to help us. Because that's my gut feeling. Yeah. And slowly, what we are talking, that we are seeing like few companies are doing their own processors, or they are exploring the risk, or the other processor sides, basically IoT. So if something, if they hit a jackpot in application, probably that would be a big thing, right? But as far as the new processor we are talking, probably the architectures are there, right? It is ARM, RISC. Yeah. So I guess we will not see a new like Intel-like architecture coming out here soon. That's what I. Yeah.
Okay. Can you please talk about that Shakti processor, like which IIT Madras have worked on? So, do you think that could be the product in the market, like where it will compete with that Intel or AMD?
It's a processor. So, I mean, why to think about like competing with Intel or AMD is a different level, right? So this is the start,
correct,
right? And So they have some positives, right? And wherever they find the application, the people will start using that, and that is where this India ecosystem or the DLI, right? They will be incentivized to use something which was created in India. Yeah. But mostly, what I think is, when you think of any industry, right, as a business, right, they would want a perfect product, and whatever fits in that, especially even in the cost perspective, right, whatever fits in that, they will go for that. And the cost is definitely on the plus side I would say the positive side for the in-house processors. Like especially the architecture with the risk is open source, and architecture is open, so some royalties they can save, and yeah, they can gain on that. Yeah, but to predict, right, it is a very difficult task. I would say if I can predict with 100% guarantee, I would go and invest in there, right? So since we have not invested, we can't really say, but it's a positive change.
You have did and completed, and you can manages many projects. So verification is one of the important step when we are doing chip designing, and it will go up to the tape out. So what parameters and how you will measure that verification is done?
Okay. Yeah. So I mean, this is the question that we face in every project, right? So what we aim for is that whenever the design comes out, it should start working, right? That is our aim. And if you backtrack it, so first of all, your all use case scenarios should work, right? If you have identified this chip to do such and such task, so those should work without any problem, right? So, and then there are some corner case, some features, some corner case scenarios. So all those things we find out when we are doing the test plan. Right? So if our test plan is properly covered, that gives us a very good confidence that this product is going to work as planned, because we would have actually simulated all the scenarios. The problem comes when, especially the bugs are found, is some area which we have not tested or which we have not simulated. What happens is, it's not possible to do the complete application scenario in simulation. You know, in simulation we run say maximum of few milliseconds, but in real life these products are running say like multiple seconds, minutes, days, right, even before they go through a reset cycle. Right? So that much simulation is not possible. So we go and try some very specific scenarios, and we try to say after this scenario the system has to return to the known state, right? So as long as you are coming back to the known state, and then you are starting another feature, another application, another mode of working, right? And then when that work is done, you come to another known state, right? When we test all these known transitions, then we think that if the chip is going through these transitions repeatedly, it will not face an issue. So we try to cover all those things in patches. And so when we are writing the test plan, right, this needs to be thought that we are covering all the patches. We are covering pretty much everything end to end. So not in one test, but in multiple test scenarios. So that's why you have a first is like sanity level test cases, right? You just clear basic thing, the chip powers on, it starts working, there's the data flow properly, yeah, whatever mode you want to run, whether you are able to read write all the registers, whatever defined in the spec. So we write the test plan, and completion of test plan should give us the confidence that the chip is going to work when you power it. That is one aspect. Another aspect is what tools are giving us is like say code coverage. So you have written some RTL with lot of features in mind. How do we ensure that all the features are really exercised or not? So that is when we do like code coverage, line coverage, expression coverage, right? Toggle coverage, right? So the problem of all these things is you cannot do 100% coverage on all the items. Right? I mean, if we have to really sure that everything is going to work, then this matrix has to be 100% covered. Right? But which is not possible, because we always have a finite time, finite resources to go to that class. So we do reviews, and so that's that's a human intervention process, and we decide, okay, this is not a use case scenario, this is not a real life scenario, or these three things may not happen in real life. So we keep on doing the waivers. So that is what we do when we do the code coverage analysis. One more way we do is functional coverage analysis. See, the test plan, if it is executed 100% properly, then probably functional coverage should also be a perfect one. But definitely when we are working, there might be few gaps here and there. To check that, we write functional coverage. Right? So functional coverage we write for some particular scenarios, we write for some specific features. So there are 100 ways you can write the functional coverage, and when that matrix is 100% covered, because that's not tool generated, right? That is written by the test planner. Right? Whoever is writing the test plan, they would have identified these points we should definitely cover in our test scenarios. Right? So when all these points are covered, we think that probably we are approaching the closure of our verification task. One more aspect that as a program manager or a project manager, I look at it is, how is a bug graph moving, right? So we want the bug graph to be fairly stable, like we should not be finding many bugs when we are doing the regression. Then if we have not hit any bugs in the past 1 week, 2 week, 3 week time, we think probability it is stable. It's only not that there are multiple ways, like you can just simply make 0 bug every week, that you don't work, right? But that's not the way, right? You need to have some of the other matrices moving up, but not the bug count. For example, if you don't write any test case, how are you going to find the new bugs, right? So that we have to say that, okay, we are adding new test cases, but we are not finding bugs, right? So if that keeps happening for 3 weeks, then I can say, okay, now the environment or the design is very stable, or whatever the features we have tested, they are stable. Regression, definitely we expect them to be debugged completely and not have any failures or unknown failures. That can be known failures, and we try to fix the test bench for those things. Yeah, so these are the techniques, and with which we deploy before we say that the verification is complete, or we give a green signal for tape out.
Okay. And one favorite topic is now going on is on AI, artificial intelligence. So how AI is transforming the design and verification process?
That's a good question. So we're yet to see. See, right now we see a lot of guys are working on making it applicable for our designs and verification, and even backend also, right? So complete flow. See, most of it, I also feel that it can be taken over by AI or the tools which are based on AI, because we are doing many tasks which are repeated, okay, which a machine can learn. And that always you feel, right? When you are doing one similar projects for multiple cycles, you will see your team members are much more effective in the next version, in the next project, right? So that means there is definitely some creativeness would be required, but there is lot of learning that they take from the past project to the future one, right? That can be done by the machines, right? So that is when the AI can do. See, for example, we are talking about, say, the most creative part in our whole verification process is writing the test plan, right? But test plan also has a method to do that, right, which can be automated. Like we had categorized also in past, like what we want. We want sanity test cases. We want this kind of scenarios. We want error scenarios. We want register read write. We also want to put functional coverage. And see, when I was doing the training, that time because you are teaching to somebody who is very much new to this industry and who doesn't know, like when you say, okay, do the functional coverage for this block, they don't understand what do you mean by that, right? So we also try to apply that learning, that whatever I have done, I just want to apply that learning and just pass it on to them in a more methodical way. That when for example, when I say, okay, you write the functional coverage, then they will say, what do I write? Where do I start? Right? And when we generally say, okay, look at the register specifications, right? And this is what you should all cover, right? All the modes should be covered. This is very easy for AI to do, right? So my understanding is the AI can do, say, like 90% of our test plan. It will do a very elaborate one. We will be working on how to make it optimal one, because when you give it to machine, it will be very difficult for the machine to say, okay, we won't be doing this, right? So wherever it finds a test scenario, it will try to put it. Yeah. So that fine tuning will happen on that. Coming to other processes, let's say for example designs. There are already like few companies in market who have done a lot of automation on design. So especially for all trivial designs, wherever we are using almost all the trivial blocks, right? Say for example, there's a serializer, deserializer is there, scrambling, descrambling is there. So like that in all sides, right? All the projects, the respective experts, they know, okay, these are the repeated blocks, and like how architect draws a diagram saying that, okay, this is what you do, and that is pretty much complete picture, right? And even the designers who have not worked on that particular technology, they would be able to implement that, right? So if a new engineer is able to implement that, I guess AI will definitely be able to implement all those things. Plus, a lot of knowledge would be there in AI systems. So now we are trying to. There are few companies, right, like who are like there are IPs, there are templates, and then you just stitch them together. Probably you will get a new IP, and if your logic is totally new and which AI is not able to do that, only that much part we will have to do. Yeah. So I am imagining that within a week we should reach to a place where architects has drawn the diagram and the RTL is ready.
Okay.
It should reach that stage. Yeah. And then next would be like, how do you architect that thing? The AI may be useful there also. Yeah, but even we have limitation on our imagination. Okay. What we can do. Yeah. Coming to verification, I see a similar thing, like lot of repeated test cases are there, lot of repeated scenarios are there. That machine should take and do without fail. AI would be very good in doing those scenarios. Backend, definitely. Backend right now, most of the companies have done so much of automation, right? They need user intervention only for a very small part. There are multiple techniques that engineers are deploying. Right? Once AI learns all those techniques, probably there will be even a smaller subset of problems that would be left for us to handle. So that is where AI would take us, and we would be working on making that AI perfect.
And one more thing is there, to run AI, we need high speed processors. So how that we are going to fulfill their requirement?
Yeah, so right now that the process already started, right? Like and everyone has seen the emergence of NVIDIA, right? So their compute capability is behind all those AI. So they are able to give the compute, they are able to split the task, use multiple, like thousands of cores to do that. So I guess that is not a big problem now. And since there is so much of a hype around that, there is a bigger investment happening, so that domain is definitely going to grow faster. And to run our AIs, we will not face the problem of compute. We need to see what cost it will come at and whether it will be beneficial for us to do that. But if not say this year, maybe next year or a year later, even our AI modules will also become efficient, that they won't need such a huge compute. They will be able to run in a pretty smaller subset. So then it may become more cost effective.
Okay.
Yeah.
One more thing I want to ask, like this is going to be new transaction is happening. Like if we go to past time when the factories came into the picture, so initially manpower were working in the factories, they were manually doing all the things. When the machines came, so huge, you can say many guys lost their job. Now machines have replaced. Now as the AI is coming, development is going on, so in what perspective we have to think in a positive, what it should be in the positive way, and what like nowadays people are afraid of, they are thinking that AI will come and they will replace him. So what's your point on that, like how we have to take that this transaction it is going to be happening?
Yeah, so for this transition, see, anytime any transition happens, even when the machine came and there was a fear that everyone will lose the job and everything machine will do, but then what happens is it opens up something new, right? So like a few factories started working on machines, but then who will make the machines, right? So that industry picked up, right? That industry became bigger, then that became more efficient, so that there were more machines required. The machines were done at a lower cost. That machine found application in other areas also. So instead of really going through like very laborsome task of human doing everything, we have moved on to the next level of machines. If for example like autos have come, right, and the human rickshaws, they're gone away, right? So that's a good transition, right? So it is helping everybody, right? We don't expect people to do like so much of a hard work. This also reminds me one more time, like when in 90s when we heard, okay, the computers are coming, and then it will replace everybody's job and all, and I'm like, as a child we were scared like whether we'll get a job or not, and it turned out to be exactly the opposite, right? That computer has given all of us job and a very good life, I would say, right, compared to like if you say like 20 30 years back what it was. Yeah, so again there might be few people who might have lost the job because they could not scale up, but barring that, I guess it would be beneficial to most of the industry. I mean, I've not come across the examples where it has completely removed the need of people. And today also, right, like after so much machines and like so much automation done, right, we are talking from the industrial revolution till now, we still have the problem of skilled labor, right? Like no one says, okay, even forget about the skilled laborers. We have a problem for doing semi-skilled laborers, right? So when we talk to the industries, they have this problem. They have more requirement, but there are not enough skilled, semi-skilled people. Right? Even you talk to the farmers, they also don't get
Correct.
they also don't get people. So it is good that at least there are machines which can help do the harvesting or do the work. Right? So similarly, AI will definitely disrupt few things, and we will emerge. We will find something else to do, and maybe that will be better.
Okay. And one more thing, like engineers are talking about edge computing and quantum computing. So can you please highlight these parts?
Yeah, means now these are the different applications, right? So these trends will keep coming, right? Something like say edge, quantum, or something else. Okay, so for example, edge. Now what we are trying to do is we are trying to do lot of processing at the place where we are collecting the data. So our previous model was we used to sense the data at one place, collect it, and send it across to some remote place. We called it server, right? And which was a big machine or a big server farm, and that would process the data, get back the results, and whatever take the action at some other remote end. So now, like so much of compute is available, and it is easy to do that kind of compute in the chips. So we would like to push that towards the edge, like where we are collecting the data itself. So process it. So that way it saves you the effort of doing a trip, like for that data to do the trip to a remote location and come back. Yeah. So that technology is definitely going to help in a lot of IoT devices where we are taking the action immediately. Yeah, even in I guess telecom sector also they are doing that. So all sectors we will go through that, and I also see this as a cycle, right? Like see, previously everything was supposed to be centralized, right? Because we didn't have so much of machines. Like if you read about the history of computers, there used to be only one computer in one university, and then the students would connect it like remotely from their classes, because you cannot really have so much interfaces, right? So that was like centralized. Then we had like desktops, and then it was kind of decentralized, and we started using the compute at our end, right? And then then we had like server farms. So wherein again we stopped doing everything at our end. We only would create the job, and job would be done by this server. So we started again doing centralization. So now we again want to move it. Like why server should do everything? We are again trying to do it decentralization. So it is coming to the edge. Yeah. So these are the cycles. So see, for a semiconductor or as a VLSI engineer, design or a verification engineer or a backend engineer, we have seen a lot of technologies making news. Yeah. But our job pretty much is unaffected by these things, because all these things, what basically they need some kind of design and some kind of verification, some kind of a backend. Yeah, so this is mostly for the guys who are going to sell those devices, sell those equipments to the end customer. Yeah. But this is what trending today, right? Edge.
Correct.
Yeah. Quantum we have not seen much. So.
But they are talking about that quantum computing, like your phone should be compressed in, like you can say, like in movies they are showing, like you will get a little bit display there, you will imagine all the things.
Yeah, I've been imagining these things
Correct.
since my engineering. Okay, so yeah, we have not seen that much of a progress. Yeah, if it happens,
Movies are more head than engineers, I think.
yeah, I guess the guy who gave them the ideas must be engineers only. That it is possible.
And uh, we will talk about the current market scenario, and previous year, like past year, we have seen the downfall in the VLSI industry. So according to you, what was that reason?
Yeah, means see, whatever I understood was like COVID hangover, right? Whatever was because in COVID time we have seen a um, big jump in all the requirements, right? Especially when we talk about our industry, right? Like services or the design. So then that has driven a lot of hiring across, right? Like all the companies have done a good amount of hiring, and I would say sometimes more than what they needed. For 2 years, whatever we saw, everything was in high demand. Semiconductor was it became a scarcity, right? So it was very much in very high demand. Supply was not there, right? So it kind of created the hype around that, and no one wanted to lose or lag behind. See, if this kind of demands continues for say another 5 years or another 10 years, so I guess everyone has done hiring keeping that trend in mind, and COVID all of a sudden it went away, and we started our normal life, and then whatever this surplus was there, right? So then that surplus was not needed, so this surplus could not get more projects for the people. Even when we look at the inventory, right? So when you have an excess of inventory, you cannot manufacture more. You have to try to get rid of the existing inventory. So that stopped new projects. Yeah, so all of this together they form this impact of companies not needing so many people, and something like market driven, right? So if there is no project, why you want to keep people? So again, like how market expects them to behave, right? So on that line, I guess they have cut down their engineering workforce, and pretty much everybody got impacted. So it started at one place, and then that domino effect has impacted many guys in our industry also a lot.
Correct. So when they can expect, like many of the engineers are waiting for the hope, like I am also getting so many messages. The thing is, like, first question is like when the market will come up, and second question is like if it will come up, what they will expect from us.
Okay. Yeah. So when it will come up, there is no concrete answer. Like as I told you, if I know, I would be putting my bets on that, right? Yeah. So in general, like what we are hearing from the past three quarters is it is 2 quarters away. Okay. Yeah, and then those 2 quarters happened, but still we didn't see so much of a turnaround. There is a small change that we are sensing, that few companies are doing new projects. They are starting new designs. So it is on that path. Whether that will be a hockey stick or that will be a very slow ramp is what we have to watch. Now coming back to the second question, right? What the engineers, right, who have who are asking or who are reaching you, right? What they should do is they have to invest time in something which is more useful. And I guess most of the guys are trained to do something, so they have to execute some projects end to end. There are so many resources available, right? So now at least there is no problem when it comes to design or verification, right? You have tools which you can use to design, to simulate, and that is most of it is like free of cost. They are available on cloud, and like EDA Playground is there. Correct. Right? And editors are anywhere, like ample of editors are there. There are, but how do you say whether what work you are doing is up to the mark or not? So that is the problem. See, many guys I have seen, even I met, so they are doing something that they were doing in the training, but they are not looking around, right? So there are, so because of that, what is happening is there is not much quality in their work, right? Their codes are not maturing. The way they are writing, their thinking is not maturing. So what they need to look at the similar design implementation, or look at the similar verification implementation. See, for example, you go on GitHub, you get a lot of implementations. You take any protocol, right? So let us compare how whatever you made or whatever you have created ranks against whatever is available on GitHub protocol, right? If you are able to rank little higher than that, then you are doing a better job, right? Then you look for another implementation. So I have seen, say for example, like AXI, it's such an open protocol, and there are like so many people who have done the AXI IPs and VIPs which are available. Even the open course was one initiative, right, where many IPs are open source. Yeah, we need to compare against that. Okay, if you are a verification engineer, you should take the open course IP and try to verify it, try to find a bug. There are few bugs there, people have reported. You need to make the environment, verification environment, to make that. If you're a design engineer, you need to code it basically. So what we are saying is that they are reading but not coding, right? So the hands-on experience is lacking, right? And whenever the situation turns back, right, so there has to be some difference. I mean, now this is I can foresee, for example, if I have a requirement, say 1 year down the line, and someone is coming with, say, who has started their career in 2 years back but are not working, right? That time I will have two choices, right? One is there will be a lot of freshers who are graduating from the college, and one like who already were trained, right? So the people who are already trained, they need to show the difference, that they're far better than the recently passed out graduates, right? So that difference, they will have to do that, and that will come only when you do many of these hands-on implementations. Okay, right? Without that, only reading. I mean, there are few guys who are smart, not about them, but most of the guys I have seen, I have interviewed, is they know pretty much on the theory part, but when it comes to implementation, they struggle. They are not able to write say a basic SPI driver. Right now, that is what is taught in all the training schools. That is where we start our VLSI journey, right? So at least that part, everyone should be very thorough with. Right? Even if someone wakes up you in the middle of the night, you should be able to do some of the verification environment of your own IP. We are not saying like do for some randomly done IP, right? Yeah, that also many guys are struggling. So they need to focus on those aspects. Right? Understand it, and keep trying, implementing it.
Okay, and nowadays, like Ethernet and PCI requirements are going high. Still, it is in high in the market. So now the engineers having doubt, like should they have to invest their time to learn PCI or Ethernet, because as we know, these are the big protocols and without any industrial experience, it is very difficult for them to understand. So what, like, they are expecting like the future market is also going to be on PCI or Ethernet, so should they will take any training institutes or join that PCI training. So what's your point, like what your suggestion to them, where they will invest on your time, like basic, like cover those basic protocols, or should they have to move to these protocols?
Okay, so there is no substitute for learning basics. I mean, you cannot say I will learn PCI Express but will not know how the basic work, or I'm not able to code basic UART, right? Or I'm not able to do AHB properly, right? So basics is very important. Even if you don't know these protocols, especially at the entry level, right? No one is expecting the freshers or the say 1 year guys to know all these protocols. So that is not the expectation. Expectation is, if we give the work to you, will you be able to do it, even with some hand holding, right? That confidence, say, any interviewer or any manager or any technical lead will get only when you have done the basics correctly. When you give the confidence that okay, I have done UART properly, right, and you are able to do it logically, you are able to understand it, right, then you will be able to like handle any other serial protocol also. At least you give that kind of a confidence. If the basics is missing, knowing PCI, CXL, Ethernet, right, in theory is not going to help, right? So basics is must. Now, should you learn all those things? You can definitely learn, right? I mean, like, why should anybody stop, right? But that should not be the reason to miss out on the basics, right? So first, make the basic. Once you are like done with UART, AHB, AXI, all those basics things, right, or any one of that, then you can also pick Ethernet. You don't have to take the whole protocol, right? You only just take a small block out of it. Right? I know the standard is big, but yeah, and without help, as you pointed out, it is somewhat difficult to know where to start and where to end. Yeah. So that challenge is going to be there. And there are some sources. Basically, there are like some YouTube videos which would give you some idea about what these protocols are and where they are used, what are their internal structures. There are few trainings also available online free of cost also. On top of that, if someone goes for say PCI Express or Ethernet training, wherein you are actually doing the implementation, it's always welcome, right? So if you can do that, why not?
Okay.
Yeah, but that would not be a prerequisite for, especially when I am talking to a 1 year experienced person, right? I don't expect them to know all the stuff.
Okay.
Right, but they should not have doubt in basic system Verilog or say when it comes to verification like UVM. That things they should know properly. They should know what a driver does, how it does. They should know how a sequencer. Basically all the connections. Right? There you should not be struggling.
Okay, because their general thought is like they are thinking, because we have seen the requirements in PCI, CXL and Ethernet, like from the, you can say previous year, the last quarter.
No, it's not for last quarter. It is for like many years. It's the same thing, right?
Okay.
So what happens is there are not many experts in these domains, so that's why these openings keep coming.
Okay.
Okay. But at freshers level, even when in our past. Since the expectations are a little different, that's not a prerequisite to know PCI Express. So as you start working on the project, there will be definitely small work carved out for depending on your experience and expertise for you, irrespective of the protocol. Right? See, when you break all these protocols also, right? Like they also come to the level of okay, this is serializer, this is scrambler, this is descrambler, this is gearbox. Like so, basically it comes down to like small blocks. This is a block which like reads data, stores into some memory, then reads out the data. Okay, yeah. So it boils down to small blocks only. So, and at that level, you expect to do small blocks only. Okay. And when it even end-to-end scenarios also, there are test plans. You can follow the test plans and do it. So that is not a difficult thing to do.
Okay.
Yeah. So I mean, knowing is good thing, but it's not a prerequisite at that level. Definitely, like if someone is saying, "Oh, I have 10 years experience," then like nobody would be interested in teaching them PCI Express, because the expectation is different, right? The expectation is you should be able to do the test plan. That means you need to have the end-to-end vision of the project or that particular block, the use cases, application scenarios, right? The corner cases, the error scenarios. Right? So basically that you need to have, and maybe at that experience level, it is fair to expect the knowledge, right? Okay. Yeah, but at freshers level or at 1 year level, it's not needed.
Okay.
Yeah. So if you have a time, spend it on like making your basics strong.
Okay. And one more thing, like we have seen the requirements in IT industry, but that much is not in the VLSI industry. So according to you, what like is that the skill set gap is there? Because of that, there are not much requirement, or what's your point of view in that?
No, the industry as such itself is a small industry, no? So like IT industry in general, it's an umbrella term for so many things, right? Like so many sectors, and they have a wide variety of requirements in those sectors. What are solutions we are providing from the semiconductor side, right? Are so far they were so generic. For example, a company made a processor, right? And then somebody made a laptop using that. Now that laptop gets used across all the industries, be it insurance, be it schools, or banking, finance. So you pick any industry, right? So this is a generic product, right? So you will not have like so many, you don't need so many variants, right? But whereas if you see the IT, especially the software which you need to service, all of this is totally different, right? The insurance company software is different, the hospital software is different, small clinic software is different, big clinic software is different. Like there are so many shades or so many variants that you need in the software side, in the software world. Right? Whereas hardware is so far very generic, right? And that's why you see the size is smaller, because whatever work we do is scaled across multiple sectors. So similarly, for example, if we design a router, right, and then that router gets used worldwide across all geographies, across all domains, so because it is independent, right? So that way, what I'm saying is the requirement itself is less. It cannot be as big as the software, and it is not related to whether it can generate the similar money or not. That's a separate part, right? But if you do one product, it is very much scaled to a very wide segment, so you will not see the jobs compared to the IT or the software side.
Okay. So thanks Mangesh for your valuable time. Hope we have like seen many doubts. So by watching these videos, like they will definitely clear out the doubt. And if they have any question, we will sync up in the next part. So thanks everyone.
Yeah, thank you, Naren.
Thanks Mangesh. Hope you guys enjoyed this episode. Please like this video and also share with your friends and colleagues. And to be updated what's coming up in this channel, don't forget to subscribe my channel. And if you have any query, you can put in the comment section. And in the description, I have given my LinkedIn ID. Please be in connect with that. So thanks for watching this video. Thanks everyone.